All right, we got question number 3 here. So assume that the interest is added on January 1st of each year. Make one graph that shows how each type of investment, simple and compound, starts with $1,000 and grows over 8 years. So go ahead and make your table. You can pause the video if you need to while you watch this. On my x-axis here, I've got years. So year 0, 1, 2, 3, 4, 5, 6, 7, and 8. We're going to go all the way to 8 years. And then for my money, I started out once again at 0, and I went by $100 increments. So you can see 100, 200, 300, 400, 500. And at that point, I stopped labeling, but I'm still going by hundreds. So 600, 700, 800, 900, 1,000, and so on. And I labeled every $500. So go ahead and pause the video and go to that, and then we'll come back and we'll start graphing the simple, and then we'll graph the compound. All right, perfect. So we're going to start by graphing the simple. I'm going to do this one in purple, so let me circle the word here, simple. So we're probably going to have to look at the back page here to make sure that we do everything correctly. But we started out with $1,000. So at year 0, I'm going to put a purple dot right at the 1,000. After that, we had 1,080. So that's going to put me right there. And then year 2 was 1,160. So that'll put me just over the halfway point right there. And year 3 was 1,240. And we're going to keep putting dots here until we get to 8. So go ahead and pause the video. When you come back, I'll have my graph done, and yours should be too. All right, so I've got all my dots plotted. I've got my purple dots that are all right there. If you continue the pattern, then I drew my line through them. So question B states, if the graph, is the graph for the bonds with simple interest a linear or exponential graph? How do you know? So hopefully you can see that that is a straight line, so it's going to be linear. And we know it's linear because all of our dots are increasing at the same rate. So I've got a constant rate. So constant rate, we can also just tell that it's in a line. All right, next thing I've got to do is my compound. I'm going to do the compound in green. So my first dot at year 0 is going to once again be at 1,000, so that's going to be the same spot. My next one is going to be 1,166 and some change. That one's just going to be a tad bit above the other dot. Go ahead and continue this pattern. Use your calculator. You'll probably need to investigate a little bit to continue that pattern after the table, after the 4 years. When you unpause your video, I'll have my graph done and we can continue with the questions. All right, 2 quick things I want to talk about. First thing is I did want to clarify, after 1 year, this point should be 1,080, and then the second year one is going to be when this point starts getting a little bit more than that one. And the second thing is that I know most of you probably guessed and checked, maybe put these into your calculator, these values into your calculation and found an answer. Don't forget we can use our table. So if you've got the equation, if you're able to come up with an equation, go ahead and put your equations into your y equals. So for my compound interest equation, I put 1,000, which was my initial value, times the 1.08, which is my growth ratio, to the x power. And then for my simple interest, I have 1,000, which was my initial amount I started with, plus 80x. And then I can go to the table by hitting second graph, and I can have my table of values. So you can see it starts at 1,000, they both go up to 1,080, and then that's when they start growing. And that way I don't have to calculate every single one of them. I can just look at the table. And I can go all the way down to 8, which has all the information I need to in order to make this graph. All right, so back to the questions. Question C, is this graph for the credit union account with compound interest a linear or an exponential graph? Explain how you know. So it's going to be exponential. And this is going to be because it has a constant multiplier. So we multiply each number by 1.08. And then also we can see that the graph is starting to curve up. The graph curves up. State the domain and range of both functions, question D. So we'll start out with the simple interest. We'll also do the compound. So I'm going to make a little table here. All right, so the domain of my simple interest. Remember, domain is my x values. So the lowest simple interest x value is 0, and that's going to go all the way to infinity. So we're going to say 0 is less than or equal to x, which is less than infinity. And actually, an even easier way of putting this, since it goes on forever, is just to say that x is greater than or equal to 0. Okay. So all my values, there's a value for x that is bigger than 0, greater than or equal to 0. So my domain for the compound interest is once again going to be the same thing. So it starts at 0, and it's going to keep getting bigger and bigger and bigger. So x is greater than or equal to 0. My range is my y values. So where along this y-axis does it begin? What's the lowest point? My lowest point would be 1,000 for the simple interest, and it's just going to keep going, getting bigger. So this is going to be y is greater than or equal to 1,000. And for my compound interest, it's the same thing. So it starts at 1,000 and keeps going up. So y is greater than or equal to 1,000. Question E, which account type grows more quickly? Explain how you know. So take a look at your graphs, take a look at your amounts on the tables on the front side, and let me know which account grows more quickly on Socrative. And then you're going to also tell me how you know. So just give me a little bit of explanation on there too for that. So make sure you put that answer into Socrative before you start the next question.